Good day. Today we are going to discuss logic. Logic is the last part in the general mathematics in the senior high school. So when we say logic, logic is the study of formal reasoning based upon statement or proposition. So take note that we are going to have statements or what we call as proposition. Logic serves as a set of rules that govern the structure and presentation of mathematical proofs. Since proofs are constructed with the English language, mathematical logic seeks to break down mathematical reasonings for a clearer understanding by using statements or propositions that are either true or false. The English language becomes the building blocks for a mathematical language. So, in other words, we are going to have statements or propositions that are essentials in making proof and validating some formulas. So, let's have an example. But before that, let's talk about what is proposition. Proposition is a declarative sentence or statement that is either true or false, but not both. If a proposition is true, then its truth values is true, which is denoted by T. Otherwise, its truth value is false and is denoted by F. Now let's look back to the proposition in English. Okay, here, a proposition is a declarative sentence. When we say declarative sentence are simply statements that relay information. They are the most common type of sentences in English language. A declarative sentence states the facts or an opinion and lets the reader know something specific. It is always ends with a period. Okay, a preposition or a statement can be presented by a small letters. Okay, let's have an example. So here we have P. Everyone should study logic. This statement can be read as P is a proposition. Everyone should study logic. So we have a small letter which represents the proposition. Now, if a sentence of prepositions is considered, so if a sequence of proposition is considered, we denote the propositions by P sub 1, P sub 2, and so on. Okay, let's have another example. Determine whether each of the following statements is a proposition or not. If it is a proposition, give its truth value. Okay, Mindanao is an island in the Philippines. So the sentence Mindanao is an island in the Philippines is a declarative sentence which can be answered by yes or no. Therefore, the statement P, is a proposition. And the truth value of the statement P is true because Mindanao is really an island in the Philippines. Another example, find a number which divides your aids. Okay. Now, in this sentence, the statement is the statement is imperative sentence. So because it's not declarative, it's imperative, then it's not a proposition. Okay. Take note that this is imperative, not declarative. Another example. Okay. My seatmate will get a perfect score in the math exam. Now, the statement is a declarative sentence which gives the information. So, this is a proposition. Okay. Now, the true value is either true or false. Okay. Although the true values will only be known after the math exam, we know that it can only be either true, which means my seatmate may have a perfect score, or not, which means she may have some mistakes, but not both. So it is a proposition, and the true values is either true or false. Another example. Welcome to the Philippines. So, in this case, the statement is an exclamatory sentence. So, since it is exclamatory and not declarative, then it's not a preposition. It's not a proposition. Okay, another example. 3 plus 2 equals 5. Obviously, the statement is a true mathematical sentence. But is it a declarative sentence? The answer is yes. The statement can be read as the sum of 3 and 2 is 5, which is a declarative sentence. So, the statement is a proposition. And since 3 plus 2 is always equal to 5, then the true value or the truth value is true. Another example. F of x is equal to the square root of x over x plus 1 is a rational function. So, this is again a declarative sentence. Since the numerator of the function is not a polynomial, the function is not irrational, and so the statement is false. But the statement U is a proposition. Take note that the statement, as I said, the statement is a declarative sentence. So since it is a declarative sentence, then it is a proposition. However, the truth value is false because, as I said, the denominator of the given function is x plus 1, which is not a rational. Therefore, the numerator is not a rational. Therefore, it's a false statement. So, even if the statement is a proposition, you can remark that a false mathematical sentence is still a proposition. Another example. What is the domain of the function? So here, the sentence is an interrogative sentence. Since it's not a declarative, then it's not a proposition. Now, let's have, okay, so it's a interrogative, then it's not a proposition. Now, there are two kinds of propositions. The first is what we call the simple, and the second is a compound proposition. So a compound proposition is a proposition formed by simpler propositions or propositions using logical connectors or some combination of logical connectors. Some logical connectors involve proposition statement P and or Q may be expressed as follows. So here, the statement, not P. Take note that P and Q are propositions. So here, it is a compound proposition if we have not P. Or in symbol, you have a symbol similar to S in horizontal form and then P. Then we have P and Q, which has a symbol of this one. So this symbol can be read as P and Q. Next, P or Q. So this is P with this symbol and Q. And then the last one, if P, then Q. So you have P, arrow to Q. So this this statement is actually the what we call as negation. Okay. And then another statement, this one is the what we call as implication. So where these symbols, okay, stands for some proposition. A proposition is simple if it cannot be broken down any further into component propositions. Now take note that P and Q is what we call as component propositions. So if the proposition has a single, uh, if the proposition cannot be formed into component proposition, then that is what we call as a simple proposition. Okay, let's have an example. Okay, for each of the propositions, determine whether it is a simple or compound propositions. If it is a compound, identify the simple components. So here, Mindanao is an island in the Philippines. Yes, from the previous example, this is a proposition. Now, if we are going to look into the sentence itself, we could say that the statement is in the simple proposition. We could not break down this statement into other component proposition. Another example, my statement will get a perfect score in the math exam. So again, this is a simple proposition because it cannot be break down into component proposition. Okay, another 3 plus 2 equals 5. Yes, it is a mathematical statement and this is a proposition, and still it's a simple proposition because we could not break down the statement into component propositions. Okay, another example, f of x equals the square root of x over x plus 1 is a rational function. So this is a simple proposition because the statement itself cannot be break down into component propositions. Another statement, it is not the case that square root of 2 is a rational number. Now, take note of the statement. It is not the case that square root of 2 is a rational number. This is a compound proposition. Okay, what makes the statement a compound proposition? Now, the statement, if you observe, there is a word not. Because of that word not, this statement can be considered as compound proposition. Since it is a compound proposition, we can now identify the component proposition. So it is not the case that the square root of 2 is a rational number. The main subject of the statement is square root of 2 is a rational number. Therefore, since the main subject of this statement is the square root of 2 is a rational number, this is our component proposition. So again, it is a compound proposition if we can identify the connectors, okay, or we can also identify the component proposition of the statement. Okay, another. Can you guess if this is a compound proposition or not? So either logic is fun and interesting or it is boring. If your answer is a compound proposition, then you are correct. This statement, either logic is fun and interesting, is a compound proposition. As you can see, the statement has these words and, which is a connector, or, which is also a connector. In other words, there are component propositions or propositions in this example. So let's look for the main subject. The main subject here is logic. The logic is fun. And the logic is interesting. And we have the logic is boring. So the logic can be fun, can be interesting, or can be boring. Therefore, these statements are our component proposition. So logic is fun. Logic is fun. No, that's logic is interesting. I forgot to edit that one. And then logic is boring. So take note, we have three propositions. The first one is logic is fun from this statement. Another logic is interesting, not fun again. So logic is interesting. And the third one is logic is boring. Another example. If you study hard, then you will get a good grades. Okay, so this is, what is your answer? This is a compound proposition. Why it is a compound proposition? Because you can have the word if and then. So since you have if and then, there are three component propositions. So the first one is you study hard, and the second one is you will get good grades. Therefore, your component propositions are you study hard and you get good grades. Another example. If you are more than 60 years old, then you are entitled to a senior citizen's card. And if you are entitled to a senior citizen's card, then you are more than 60 years old. So, can you guess if this is a compound statement or a simple compound proposition or simple proposition? If your answer is simple proposition, then sadly to note, this is a compound proposition. So why can we say that this is a compound proposition because you can have in the statements if, then, another if, the and, the if, and the then. Okay, so we have these component prepositions. You are more than 60 years old. You're entitled to a senior citizen's card. Then you have, you're entitled to a senior citizen's card. I forgot. You are more than 60 years old. So in other words, you have four propositions. But if you were look into these four propositions, you have repeating sentences. You are more than 60 years old. You are more than 60 years old, and you are entitled to a senior citizen's card. You're entitled to a senior citizen's card. So you have two propositions. The first one is you are more than 60 years old, and you are entitled to a senior citizen's card. Now, if we are going to, okay, that one. If we are going to make the statements into a symbol form, then you have this one. Okay, the first compound proposition in the example, not A. Okay, so you have not, the word not, which makes it a compound proposition. So in symbol, you have this one. Okay, you have this one. Another, the second statement, B and C or D. Take note. The second example of the compound proposition there is logic is fun, logic is interesting, logic is boring. So here, logic is fun and interesting. So we have logic is fun and interesting, or it is boring. Okay, another, if E, then F. So we have an implication. The statement E implies F. And the last example, if G, then H. And if H, then G. So this would be the symbol. Okay. Thank you for listening. Prepare for a quiz tomorrow. Good luck, guys.